Hi everyone, welcome back to the channel. Today we're going to explore a topic that's really exciting and very relevant in today's world: electric cars, or EVs. You may have seen them on the roads, or maybe you're considering buying one. But have you ever wondered how these cars actually work? Unlike traditional cars, electric vehicles don't have an engine that burns fuel. Instead, they use electricity to move. This makes them quiet, eco-friendly, and highly efficient. In this video, we'll break down the science and technology behind electric cars. We'll explain their key components, how they work, and what makes them so different from regular cars. By the end, you'll have a clear understanding of electric vehicles, whether you're a car enthusiast, a student, or just curious about technology. So, let's get started. Basic principle of electric cars. Let's begin with the most important question. What makes an electric car different from a regular car? The main difference is simple. A traditional car has an engine that burns gasoline or diesel to produce power. An electric car uses electricity stored in a battery to power an electric motor, which turns the wheels. This means there's no combustion, no exhaust, and almost no noise. In fact, if you've ever ridden in an EV, you'll notice how smooth and quiet it is. Now, the battery provides electricity in the form of DC, or direct current. But the motor usually requires AC, or alternating current, to work efficiently. This is where the inverter comes in. The inverter converts DC to AC, allowing the motor to run. Think of it this way. The battery is like the fuel tank, storing energy, while the motor is like the engine, using that energy to move the car. Simple, right? Battery pack. Next, let's talk about the battery pack, which is often called the heart of an electric car. The battery stores the electricity that powers the car. Most EVs use lithium-ion batteries, similar to the ones in your phone, but much larger and more powerful. A battery pack is made up of many smaller battery cells combined together. These cells work together to provide the voltage and capacity needed to power the car. For example, some electric cars have battery packs with 400 volts or more. The total energy stored in the battery is measured in kilowatt hours, or kilowatt hours. The higher the kilowatt hours, the farther the car can travel before needing a recharge. Safety is a big concern too. Modern EVs have cooling systems and battery management systems to prevent overheating, ensure safety, and extend battery life. So essentially, without the battery, an electric car cannot function. It truly is the heart of the vehicle. Electric motor. Now let's move on to the electric motor, the component that actually makes the car move. The electric motor converts electrical energy from the battery into mechanical energy that spins the wheels. Unlike a traditional gasoline engine, electric motors provide instant torque, which means fast acceleration right from a standstill, operate quietly, producing almost no noise, require less maintenance as there are fewer moving parts. There are two main types of motors used in EVs: AC motors, which are common and very efficient; DC motors, which are simpler but less common in modern vehicles. Some cars even use dual motors, one for the front wheels and one for the rear wheels, which provides all-wheel drive and better control. So the motor is really the engine of an electric car, even though it works in a completely different way than traditional engines. Inverter and control system. Next, let's talk about the inverter and control system. The inverter is a crucial component. It takes the DC electricity from the battery and converts it into AC electricity that the motor can use. But that's not all. The inverter also controls the speed and torque of the motor, allowing the car to accelerate smoothly and efficiently. The control system, sometimes called the vehicle's brain, monitors motor performance, battery health, power distribution, regenerative braking. Together, the inverter and control system make sure the car runs safely, efficiently, and reliably. Without these systems, an electric car wouldn't be able to perform as smoothly as it does. Charging system. Now, an electric car runs on electricity, so charging is essential. Most EVs have a charging port, similar to a fuel tank in a gasoline car. You plug it in, and electricity flows into the battery. There are different types of charging. Home or slow charging, usually overnight using a regular wall socket. Fast charging, commonly available at public charging stations, which is much quicker. Supercharging, found in high-end EVs, can charge up to 80% in just 20 to 30 minutes. Charging speed depends on the battery size, the power of the charger, and how full the battery already is. So, while EVs don't use gasoline, they still need time to recharge, which is an important consideration for drivers. Regenerative braking. One of the coolest features of electric cars is regenerative braking. When you press the brake, the electric motor acts as a generator, converting some of the car's kinetic energy back into electricity. This electricity is stored in the battery, which extends the car's range. It also reduces wear on traditional brakes, meaning less maintenance and lower costs. So every time you slow down or brake, you're actually recovering energy instead of wasting it. Advantages and disadvantages of EVs. Electric cars have many advantages. They are eco-friendly, producing zero tailpipe emissions. They are quiet, reducing noise pollution. They have lower maintenance costs because they have fewer moving parts. However, there are also some challenges. Batteries can be expensive to replace. The charging network is still growing, so long trips may require careful planning. Despite these challenges, EVs are widely seen as the future of transportation as technology improves and governments promote cleaner vehicles. Conclusion. So today we learned a lot: how electric cars work, their key components, battery, motor, inverter, and control system, charging and regenerative braking. Advantages and limitations of EVs. Electric cars are innovative, efficient, and environmentally friendly, and they're reshaping how we think about transportation. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more tech explanations. Also, comment below and tell us which topic you want us to cover next. Thanks for watching, and see you in the next video.